Hello, everybody. So this is the last video in this first section on confidence intervals for proportions. This one's going to be pretty short. This is a type of problem that shows up every once in a while on free response, sometimes on multiple choice, but it's about choosing a sample size. So every once in a while, you'll come across a problem where they'll tell you what they want the margin of error to be. They'll say they want it to be like within 2% or 3% or 5%. And they'll tell you the confidence level that they want to use. And what they want to know is, okay, if I want this margin of error at this confidence level, how large of a sample do I need? How many people, how many things do I need to sample? Okay, so essentially what you're doing, right, is you're taking the back half of the confidence interval formula, right? So not the p hat part, but what comes after the plus minus, because what comes after the plus minus is your margin of error, okay? And you're resolving that inequality for n, which is the sample size, okay? So really quickly, I'm going to show you on the left side how you would do that, like what the actual math looks like in maneuvering these different variables around. Okay, so I'm starting with z star parentheses p hat 1 minus p hat divided by n, and I want that to be less than or equal to the given margin of error. Okay, so first thing I'm going to do is divide by z star on both sides. So I end up with this p hat 1 minus p hat over n is less than or equal to your margin of error divided by z star. Okay, then I'm going to square both sides to get rid of this square root right here. Okay, all right. And remember, I'm squaring like this whole fraction, okay? So I end up with p hat 1 minus p hat divided by n less than or equal to margin of error divided by z star squared, okay? Now, there's a couple of ways that you could do this, right, in order to get n by itself, but I think that the easiest way is to flip both of your fractions, right? So instead of n being in your numerator, change it to the denominator. So you have n over p hat 1 minus p hat, and then you have z star divided by the margin of error, okay? But whenever you do that, if you do that, the rule here, right, is that you have to switch your inequality, okay? And then the last thing I'm going to do to get n by itself is just multiply both sides by p hat and 1 minus p hat. So my final formula here is n has to be greater than or equal to, oh, and I forgot my squared up here, z star over the margin of error, that fraction squared times p hat times 1 minus p hat. Okay, now if you want to memorize like this version of the formula, you absolutely can, but you can go through and just plug these values into the formula that they give you and resolve for n, right? So if you are like really confident in your algebra skills and you feel like you can do that quickly, awesome. Just go ahead and do that rather than having to memorize the formula. If you're like, I don't trust my algebra skills under pressure, then maybe I would memorize that formula, this final one right here, this guy. Okay, because what they're going to give you on the actual AP test is this formula. Okay, like that's all you'll have, right? And they won't even give it to you this way. They will just give you the confidence interval, like the breakdown of the confidence interval. You will have to know to take the back half of the confidence interval equation and say that that's less than or equal to the margin of error. Okay, so I'm going to write these values for you over here. So my general sample size formula starts as z star square root of p hat 1 minus p hat divided by n has to be less than or equal to the margin of error. Okay, if you resolve this for n, what you end up with is n has to be greater than or equal to z star divided by the margin of error squared, okay, times p hat times 1 minus p hat. Okay, now the question then becomes, okay, what do you use for p hat? Okay, if it's given to you in the problem, like they give you a sample proportion, use that. So either use a given value, or if they don't tell you the sample proportion, use 0.5, okay, or 50%. And the reason you do that is because that's going to give you the largest possible margin of error, right? Because if p hat is 0.5, you're going to end up within your fraction with 0.5 times 0.5. Any other value will give you a slightly lower product than 0.5 times 0.5, right? So because of that, that 0.5 as p hat is going to give you the largest possible margin of error. So you definitely will be able to hit your desired margin of error, right? It's going to give you the largest possible, and it'll result in the largest possible sample size, essentially. Okay. All right. So let's take a look at this question, right? So we're talking about a company that's received complaints about customer service, okay, and they're going to hire a consultant. But they want to know before they hire this person and spend a bunch of money on it, they want to know how big of a sample do I need, because that's how many people they're going to have to pay for, right? So what this company is trying to figure out is they want to estimate the proportion of customers who are satisfied with their customer service. Okay, she wants a 3% margin of error. So my margin of error is 0.03 at a 95% confidence interval. So the question is, how big of a sample do I need? Okay, so first thing I told you to do is find z star in your sample proportion. Okay, my 95% confidence means my z star is, again, 1.96. Okay, and then my sample proportion, they gave me nothing. They did not give me a sample proportion. So p hat is unknown. So that means I'm going to use 0.5. Okay. And then because I have my lovely equation already resolved for n up here, I'm going to actually write that out and plug my values in here. But what I will show you on the left side of the screen, let me do some erasing here, is that I did show you on the left how you would actually go through the arithmetic that you would do if you wanted to start from this formula, right? The original one, and actually go through and solve that, plug values in and solve that for n. Okay, but because I have this formula, I'm just going to go ahead and use that one. Okay, so what I have here is I know that, so I'm looking for n. So n has to be greater than or equal to, so z star is 1.96 divided by, my margin of error is 0.03, and then I'm going to square that times p hat is 0.5, and then 1 minus 0.5. All right, I'm just going to plug all of that into my calculator. And when I did, I got that n has to be greater than or equal to 1,067.11. And since I'm talking about people, that means that my sample size has to be at least 1,068. Okay, so sample size must be at least 1,068 people, right? you can't round down here, right? Because we're saying n has to be greater than or equal to this value. So if you round down, then your inequality is not satisfied. Okay, so we've got one more here. So what I want you to do is try this out. Okay, so go ahead and pause the video, give this a try, right? Try this question and then check back with me to see how you did. All right, folks, so go ahead and check your answers against mine. So in this problem, we're talking about a national opinion poll that found that 44% of all American adults agree that parents should be given vouchers that are good for education at any public or private school of their choice, right? And they want to know first how large a sample would have to be in order to get a 3% margin of error at a 99% confidence level. Okay, so your Z star value, your critical value for 99% is 2.576. You could have rounded, that's fine, and used only 2 decimal places instead of 3. If you did, your number may be slightly different than mine, but like close enough. Okay, and here, because they gave me a proportion, right, I'm going to use the proportion that they gave me. So I'm going to use 0.44 as my p hat value. And I just plugged all of my values into my formula, and I got n has to be greater than or equal to 1,816.73. So I rounded up to 1,817. Okay, for part B, it says this time we're going to use our most conservative guess of 50%, because that's going to give us our largest possible margin of error, right? Like it'll get us closer to that margin of error, right? So you're essentially like guaranteed, if you choose this many people, no matter what your proportion is, your p hat is, that you will have at the very least that 0.03 margin of error. Okay, so again, my Z star value is 2.576, but this time p hat is 0.5. So I plugged all of my values into my formula. I didn't write 1 minus 0.5 here for the second one. I'm hoping that it's understood that 1 minus 0.5 is 0.5. Okay, and I went through, plugged all of that into my calculator and got n has to be greater than or equal to 1,843.27. So I rounded that up to 1,844 adults. All right, folks, so that is it for this problem. That is it for this section. So I will see you in the next section. The next set of videos is talking about hypothesis tests, right? So get ready for that, and I'll see you in the next one. Bye, everybody.